Example number 95. Solve the logarithmic equation log 4 minus w to base 5, then minus 2 log w to base 5 is equals to 1. So here, we have the same base. So when we have the same base, we ensure everything has the same base, isn't it? We ensure everything has the same base. So here we have log 4 minus w to base 5, then minus 2 log w to base 5 is equals to 1. Then we introduce log 5 to base 5, because log of a number to the same base is 1, isn't it? Yes. So we have base 5, base 5, base 5 for everything. So we can now use the laws of logarithm, isn't it? Because there's no multiplication or division sign between the logs, isn't it? So we now go on, we get rid of the coefficients, okay? So if you get rid of the coefficient, we'll have, the first case here, we have log 4 minus w to base 5, then these two coefficient become the power, isn't it? So there we have minus log w squared to base 5 is equals to, coefficient becomes the power, isn't it? Is equals to log 5 raised to power 1 to base 5, isn't it? After getting rid of the coefficient, you go to the next step. Both left hand side of the equation and right hand side of the equation must be one term, isn't it? So if you factorize out log to base 5, where subtraction will go to division. So we have for w, the subtraction changes to division, then we have w squared. So you factorize that out, meaning this divide by that. If you factorize out log to base 5, isn't it? If you take it back inside, division goes back to original subtraction, isn't it? So that one is equals to log to base 5 raised to power 1. 5 raised to power 1 is just 5. That is already one term, so there's nothing you are joining it with, isn't it? So what do? You just ignore logs on both sides of the equation once you made it one term on either side, isn't it? So once you ignore the log, what do you remain with? 4 minus w over w squared is equals to 5, isn't it? So can you now get rid of the denominator? Meaning you multiply both sides by w squared, isn't it? If you multiply both sides by w squared, what do you get? What do you get? That goes with that, you get 4 minus w is equals to 5w squared. So if you take this one to the other side, you get 5w squared minus w going the other side is plus w, positive 4 going the other side is minus 4 is equals to quadratic, isn't it? So quadratic equation, which numbers gives you a product of negative 20 and a sum of plus 1? If factorization is working, you use factorization, isn't it? If factorization does not work, use quadratic formula. Are you clear? So those numbers are 4 and 5, but which one is negative? Because here is positive, meaning 5 is positive, isn't it? Yes. So it is plus 1 negative 4, isn't it? So we'll have 5w squared plus 5w minus 4w minus 4 is equals to 0, isn't it? So from there we now have 5w is common there, then we have w plus 1, then there negative 1, negative 4 is common, isn't it? Then you remain with w plus 1 is equals to 0, because negative to positive goes back to your negative, isn't it? Then we have, open this is 5w minus 4, or w plus 1 is equals to 0. So this means either w minus 4 is 0, or w plus 1 is equals to 0. So if you solve this first case, you get w is equals to 4 over negative 4 going the other side is 4, divide both sides by 5 is 4 over 5, isn't it? And this side you get w is negative, isn't it? Because these logs are not absolute value, meaning you ignore the solution which is negative, isn't it? So we get w is equals to 4 over 5. Are we together there? So that is how to handle a problem of that nature.